Good day, my dear students. I am Ginang Elma Estema Isip, your Science 8 teacher.
Welcome! Are you excited for a fun learning session?
Kindly make sure you have the following before we start: learning packets, pencil or ball pen, notebook, and a calculator. But first, kindly answer your pre-test. Today's science lesson is all about sound. The science of sound is a transfer of energy, and most of it is used to create tunes and music for entertainment. Our gadgets are sound embedded to amuse us. Sound is also useful in the field of geology, oceanography, and medical purposes. Moreover, some animals are dependent on sound for movement. In your previous grade level, you have learned that sound waves are longitudinal waves that exhibit characteristics such as frequency, amplitude, and wavelength. Wavelength is the distance between two consecutive crests or the two consecutive troughs. Amplitude, on the other hand, is the distance from the center line to the top of a crest to the bottom of a trough. And frequency is the number of waves produced and past a point in 1 second. Sound waves have two parts: compression, which are particles are close together, and rarefaction, part of a sound wave in which air particles spread out. Sound is a form of kinetic energy that results from the vibration of particles in a medium. We also need to remember that temperature is a condition that affects the speed of sound. Like sound, heat is a form of kinetic energy. As the temperature becomes higher, molecules gain more energy and vibrate faster, such that when the molecules vibrate faster, sound waves travel more at a fast speed. We can also say that as the temperature becomes lower or cooler, molecules loses kinetic energy and thus vibrate slower. When molecules vibrate slower, the speed of sound decreases. When the temperature of air increases, the speed of sound also increases. Sound moves 344 meter per second in a 20 degrees Celsius in air. However, if the air temperature is 0 degrees Celsius, sound moves through it at a speed of 331 meter per second. Why do you think so? A sound moves through air when vibrating particles come into contact with other particles. As the temperature of air increases, molecules of air collide more often because they are moving around faster. As a result, sound waves move through warm air faster than it moves through cold air. Since molecules in liquids and solids are close together, temperature has less effect on the speed of sound through them. Now let's try to answer activity 1 entitled Cool Down or Heat Up. Based on what we have learned, we can say the following. During the daytime, the air near the ground is warmer than the layers of air at the high altitudes. The air layer near the ground is less dense. And at night, the layers of air near the ground cools faster than the layers up high. The air layer near the ground is denser. Therefore, the sound can be heard easily at night. The table shows the speed of sound in air at various temperature. Plot the values on the graph given at your learning packets. Try to answer the guide question as well. To answer the number 2 on guide question, let us try to watch this video. As for your first assignment, you are going to answer the guide questions number 3 and number 4, as well as the checklist out. Also, please do the activity number 3, entitled Faster Sound in Hotter or Cooler. Through this, you are going to investigate the effect of temperature on the speed of sound. Knowing the formula for determining the speed of sound, let us try to calculate the following: 10 degrees Celsius, 35 degrees Celsius, and 60 degrees Celsius. In summary, let us remember the following. You are also going to answer the post-test and the reflection. Please follow the instruction given on your learning packets.